Hey, take a look at this. This is an unequal intersecting pitch roof. This section is a 10-12, and this is a 6-12, and this is a valley in plan view. This is a gable, that's a gable. And you can see, if left alone, there'd be inconsistent overhangs. But the architect is calling out consistent overhangs of 16 inches. So this valley will have to slide over in the drawing so that it terminates out here. And we want to establish how far. First thing we want to know is, how did we get this valley in plan view? And the answer is by the use of the miter ruler. But in this case, we can just take the rises, because there's a relationship between the rise and run of one pitch to the rise and run of the other. The runs are both 12 inches, so you can drop the denominators and just use the numerators and divide them by each other, which is the same as drawing a roof in plan view at a 90-degree angle. This would be the 6-12, this would be the 10-12. In this case, the span is 5, which is half a 10, and 3, which is half a 6. Run them past each other like a piece of door trim. And mark a miter out. That's the angle in plan view. That's because there's a relationship between the spans of the roof and the rises of the roof. So label them. This is the 10-inch leg. This is the 6-inch leg. 6 divided by 10 is 0.6. 10 divided by 6 is 1.66. So you label them like that. And then as far as the overhang is concerned, these triangles here you see are always going to be the same. This big one and this little one here, of course, right? So if this leg was 16 inches, which is what the overhang is, right? Then this leg would be 0.6 of 16. So here I have 0.6 of 16 equals 9.6. 16 minus 9.6 is 6.4. So that's how far you slide over. That's what this little section here is left over. So if you slide it over 6.4, the value will come at the same angle in plan view and terminate right there. 6.4 inches to the center line of the valley. But you remember, the valley has to lengthen up top, right? You know, when you slide it over, this ridge raises, right, immediately, because the rafters are taken off from here, not here. And when they take off, by the time they get there, they're already higher. This ridge raises, then it's longer, and this valley slides over. It meets it out here. So that's important. Remember, whatever you do down here, you got to calculate out there. So now that's established. Now let's figure out how much higher the plates are from here, which are going to be the low plate. Valley lands on the low plate. The high plate has to raise. Why? Because it was normally leaving here, and by the time it got to the plate, it wasn't as high as it would be if it left from here, right? So we want to know what this little distance, essentially the triangle of this little distance here, how much would the short run, rise, hypotenuse, right? And you essentially just take the two triangles, the 6-12 triangle, which 6 divided by 12 is 0.5 times 16 is 8 inches, right? This one rises 8 inches from the line length of it to the plate. And we want to know how much this one rises at 16 inches. So essentially it's 10 divided by 12 times 16 is 13.3 minus 8 inches. Let's see what that is. Let's say 13.3. What is it? 13.3 minus 8 equals 5.3. That was on the calculator. So this plate height is 5.3 inches higher than this plate height before we messed around with it. But take a look at this. What we want to do is we want to figure out how to slide. Now what I've done is I made this an outside corner, because what I want to do is establish how, in what way can we keep from having to back the bastard valley. In this case, it's a valley. You can slide it back and forth, and so that the sides of the valley or hip run through the plates at the same location as each other, essentially establishing 0 heel stand on either side. That is to say, with a block of wood or a calculation, would be 0 heel stand would mean that if you added a heel stand on this side, it'd be the same as on this side. As it is now, because it's coming at an odd angle, the it terminates further in a spot where the heel stands are going to be inconsistent on either side. Hence, you have to back them in order to have consistent heel stands on the common rafters. But there's a method for that, and that method is simply to take a square line off of the center line and draw a little square line off the center line, the distance that is equal to the overall thickness of the, in this case, valley. So slide it along and measure. In this valley, I believe, is 3.5 inches, let's say. Make a mark at 3.5 inches on the piece of paper or plywood, and then you square back to the building. Now you don't square off of the line you just made. You square off of the building and make a mark, and then of course you square off from that mark. You square off of the center line of the valley and slide on through. And then that's the new location of the valley. You find the center line, and you measure from the center line to the new center line to the old center line, and that's how much you have to move it inboard. So in this case, that's the center line of the valley, the new center line. In this case, it's 13/16. So you would move the 6.4 inboard 13/16, so it'd be less. It'd be 6.4, which is 7/16, minus 13/16, it would be, 5 and 0.8 or something off the corner to center line. And then you don't have to mess around with it. Now remember, whatever you do down below, you have to do up above. The fastest and most accurate way to calculate the difference between plate heights is to lay down your steel square, draw a line 16 inches and a line 24 inches and mark 12, and mark the 2 rises, in this case 6 and 10. Draw a diagonal line through them, run them wild, then slide the thing on to 16 inches, make a mark through the 2 and measure the distance. That's the plate height difference between the steep pitch and the shallow pitch. Remember, the steeper pitch plate height has to rise because you just widen the span. The span was going to be to here, now it's to here, because you move the valley over, and when it changed directions, you widen the span, so it's taken off earlier. You have to raise these plates. Valley lands on the lower one.